In this video lesson, you will be solving systems of equations using substitution. The method of substitution works by solving one equation for one variable. You can choose whichever equation you prefer. It doesn't matter, either equation is correct, and you can choose whichever variable you would like. Once you have chosen the lucky equation and variable, you plug this back into the other equation. In other words, you substitute for the chosen variable. The last step is to solve for the remaining variable. So let's consider this system of equations. We have 2x minus 3y equals negative 2. This is in standard form. We have 4x plus y equals 24. This is also in standard form. I'm going to choose this equation, and I am going to choose that we are solving for y. So what I'm going to do is I'm going to convert this into slope-intercept form because I need to be sure that one of my equations is in slope-intercept form, y equals mx plus b. So 4x plus y equals 24 now becomes y equals negative 4x plus 24. Now that I have my new equation and I have this equation equaling to one variable of y, I'm going to take this equation and plug it in to the y of our original or our first equation. So if I write out my first equation, it looks like this. And now I'm going to go back and replace the y with this y equation. This right here is the value of y. So let me rewrite it. Again, I just took the original equation at the top, replaced the y, that was right here, with my new equation. My new equation just rewritten in slope-intercept form from my original 4x plus y equals 24. So now what I'm going to do is I'm going to solve this by distributing and then combining my like terms. So my first step would be to distribute this negative 3 into the parentheses. And now that I've distributed, I'm going to combine my like terms. And now I will solve for x. And my value of x is 5. Remember, I'm not done because I'm looking for the coordinate point in which the two equations meet. In other words, the solution to this system of equations. So I'm going to plug the x equals 5 into either of the two equations. And again, I've chosen the second equation. And when I plug in the value of x as 5, so when I plug in 5 for x, I have 4 times 5 plus y equals 24. 24 minus the 20, which was the product of those two numbers, leaves me with y equals 4. Therefore, the solution to this system of linear equation is the coordinate point of 5, 4, meaning the x value is 5 and the y value is 4. Again, that is the point where our two lines intersect. This is the solution to our system of linear equations. I'm going to refer to page 55 in our textbook for our next example. As the book says, writing the equations in a linear system in y equals mx plus b form is not always easy. Sometimes the arithmetic can become messy. For example, we're going to consider how you would solve this system. Solve both equations for y to get y equals mx plus b form. So 3x minus y equals 5 now becomes y equals 3x minus 5. 2x plus 5y equals negative 8 now becomes y equals negative 8/5 minus 2/5 x. Because they are both set equal to 0, I can set them equal to each other not 0, I'm sorry. Because they're both set equal to y, I can set them both equal to each other. And then go through and solve for x. So what we've done actually in this one is we have set them equal to each other. In other words, we have solved using equality. But because this gets kind of messy with these crazy fractions, we're going to demonstrate the same example, but we're going to use substitution. So here's the same system. And instead of solving it using equality, like the book explained can be sometimes complicating, I'm going to use this with substitution. So remember, I have to choose one equation and then choose which variable I am solving for. So I am going to choose this first equation, and I am going to solve for the variable of y. So I'm going to rewrite this system as y equals 3x minus 5 and 2x plus 5y equals negative 8. Since this equation is set equal to y, I'm going to take this y value, plug it into this equation, and then solve for x. So before I substitute, my equation looks like 2x plus 5y equals negative 8. And like I said, I'm substituting. I'm going to substitute this equation for the value of y. So it now looks like this. 2x plus 5 times the quantity 3x minus 5 equals negative 8. I'm going to solve by distributing and then combining like terms. My first step is to distribute, and I get this. My next step is to combine like terms, and I get this. And now I'm going to solve for x. Divide by 17, and x equals 1. Again, remember, I'm not done. This is not the solution. This is just one part of the coordinate pair. So if my x value is 1, I'm going to choose any of my equations above and plug in that value to get my y value. I'm going to use that first lucky equation again. 3x minus y equals 5 becomes 3 times 1 minus y equals 5. When I go through and solve for y, y equals negative 2. Therefore, the solution to this system is 1, negative 2. Again, this is the coordinate point where those two lines intersect on a coordinate grid. The solution to this system of equations is 1, negative 2. A few hints to remember. First of all, choose one of the two equations and choose one of the two variables. Either equation or either variable you choose is absolutely correct. Choosing one over the other is not going to give you a wrong answer. Remember, one of the two equations must be in y equals mx plus b form. Again, the other one would be in standard form. That way you can substitute the variable of y within the other equation. And again, don't stop at solving for x. Once you find x, go back into the equation and find y. Make sure you find both variables so you have the coordinate pair, because what we are finding is the solution to the two lines, the solution being the coordinate pair. I almost forgot a joke of the day. Today's joke is, what did one elevator say to the other? I think I'm coming down with something. Ha ha ha, that was so funny. Make sure you are asking me questions if you have any on substitution, and that if you are struggling using substitution to solve systems of equations, that you are asking and getting some help. Thanks.
Made with Doodlecast Pro.